Hello, this is Charlene. We're going to be adding, subtracting, multiplying, and dividing functions. We could also call this function computation because we're going to be doing these four mathematical operations. Okay, the first function they give us is f of x, and the f of x function is x squared minus 3x plus 1. And the second function, g of x, is equal to the square root of 8 minus x. And then the h of x function is going to be 2 divided by x plus 1. And it tells us to evaluate the function, if possible, no decimals. Okay, so the first one says that we're going to take the f function and we're going to subtract the g function. And we're also going to evaluate it for the value of negative 8. So let's go ahead and do that. We're going to go ahead and grab our f function, which is going to be x squared minus 3x plus 1. And then I'm going to subtract, so minus, and subtract all of the g function right here. So my g function is right here, so it's square root of 8 minus x. And then I'm going to evaluate both of those functions with a negative 8 in them. So I'm going to put a negative 8 inside everything where there is an x. Okay, so negative 8 squared. And when you do this, if you do this on a calculator, you need to put those parentheses around that negative 8 to make sure that your calculator understands that both the negative part and the 8 are squared. So do not put negative 8 squared into your calculator. It may not give you the right answer. Okay, so minus 3, and x is going to be equal to the negative 8 plus 1 minus square root of 8 minus a minus 8. Okay, and we just keep working it down using our order of operations. Okay, so negative 8 times negative 8 is a positive 64. And negative 3 times a negative 8 is a positive 24. And then plus 1. And then minus, and under the radical, I'm going to do 8 minus a minus 8, which merely means 8 plus an 8, which is 16. And I continue to work it down. So 64 plus 24, that's going to be 88, plus 1 is 89. And minus the square root of 16. Square root of 16 is going to be 4. So my final answer is going to be 89 minus 4, which is 85. Okay, so that's how we would subtract the f function minus the g function and evaluate it for a value of negative 8. 85 is the final simplified answer for this function computation. Okay, our next function computation is going to be taking the g function and multiplying it times the h function and evaluating it for the value of 0. So here is my g function and here is my h function. So let's write those down. My g function is square root of 8 minus x, and I'm going to multiply that times the h function, which is 2 divided by x plus 1. Now I'm going to go ahead and put a 0 in for the x value. So it's going to be square root of 8 minus 0 times 2 times 2. There's a times sign right there. Times 2 over 0 plus 1. And I just use my order of operations to keep working it down. So it's going to be 8 minus 0 is just going to be 8. So square root of 8. And then times 2 over 0 plus 1. Well, 0 plus 1 is just 1. And 2 divided by 1 is just 2. So we want to simplify this as much as possible. So we're going to look at the square root of 8. Break it down if we can. So square root 2 times 4. Well, I can take the square root of a 4. So that means I can bring a 2 out to represent the square root of 4. But the 2 Loosey-goosey 2 has to stay in the house all by itself. So I'm going to note that differently. So the 4 comes out, 2 comes out to represent the square root of 4, but the loosey-goosey 2 is going to have to stay in the house by itself. So that means it would be 2 radical 2. So square root of 8 is equal to 2 radical 2. Okay, so 2 radical 2 times 2. So my final answer is going to be equal to 2 times 2. 2 times 2 is going to be 4, and then radical 2. So that is as simple as I can go. So when I multiply g times h evaluated for 0, it gives me a final value of 4 radical 2. Okay, our next problem says that we're going to take the h function, and we're going to add the g function. So here is my h function, and here is my g function. Okay, so I've got 2 divided by x plus 1. That's the h function. I'm going to add them. So g function is plus radical 8 minus x. Okay, now I'm going to evaluate them for negative 1. So this is going to be 2 divided by negative 1 plus 1 plus radical 8 minus 1. Okay, so if I work it down, I ended up with 2 divided by 0, 2 divided by 0. And this over here would be 8 minus 1, which means 8 plus 1, which is 9. And the square root of 9 is 3. Okay, so here's the deal. This piece of what we have is undefined because a 0 in the denominator is a big no, 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 no. So my question is, can we have an answer that part of it is undefined and part of it is defined? Can that happen? Well, no, that cannot happen. So let's do it another way so we can see more clearly why this cannot happen. Okay, so here I started out with a fraction or rational expression. And if I want to add this and this, then I have to have the same denominator. So I am going to rewrite these so that they both have the same denominator. Okay, so I've got 2 divided by x plus 1, and I want my radical 8 minus x to also have a denominator of x plus 1. So that means that I would also have to multiply the numerator times x plus 1 as well, because essentially there's an invisible 1 right there. I'm multiplying the 1 times x plus 1, and now I have to multiply my numerator also times x plus 1. Okay, so now both of them have the same denominator and the same denominator, which means I can now add these two rational expressions. Okay, so that means I end up with 2 plus radical 8 minus x times x plus 1. All that's in the numerator, and they both have the same denominator. So everything is over the same denominator. And now if we plug in our negative 1, then my denominator is still going to end up with negative 1 plus 1, which gives me a denominator of 0. So the entire thing, no matter what I do, it is undefined. So the final answer here is undefined because there is a 0 in the denominator. And if there's a 0 in the denominator, that means that the universe has just exploded into smithereens and it no longer exists. But this kind of confirms that even though it looked like I had one part was undefined and one part was defined, that's actually not allowed. And this confirms that because everything ends up with a 0 in the denominator. So the final answer for this function computation is undefined. Okay, this next one has a different set of instructions. It says to evaluate and write the domain in interval notation. So we're going to take the r function, we're going to subtract the t function, evaluate it for the x. So my r function is right there, and my t function is right here. So I am going to put r function x squared plus 8 plus 8, and then I'm going to subtract. So subtract all of the x plus 4 function, x plus 4. Okay, so it's uh, important that you understand that when you're subtracting, that you need to distribute the subtraction sign or the negative into every piece of the function that you are subtracting. So let's do that first. So x squared plus 8, and then minus x, and then minus negative 1 times the 4, which is going to be negative 4. Now let's combine the like terms. So it's going to be x squared plus 8 minus 4. So plus 8 minus 4, which is going to be plus 4, and then minus x. Okay, that is not in standard form, so we're just going to rearrange it. So it's going to be x squared, then the x term, so x squared minus x, and then plus 4. So that would be evaluating it, and everything is still just evaluated for x. So we didn't have to change anything because the variable in both of these was already x, so nothing changed there. But this is going to be this as simple as this is going to go. This is my new function where I take the two first functions and I subtract them and I create a new function. Okay, but they want us to think about the domain of this function. Okay, so if we know what kind of a function that is, that makes our life a little bit easy. So do you remember what kind of a function has an x squared in it? X squared means that it is a quadratic. X squared means it is a quadratic. So if this is a quadratic, what does it look like when we graph it? Quadratic, I can't write here, quadratic. When we graph a quadratic, it looks like a parabola. Parabola, which means, and there's a plus positive in front. So it means it's a happy parabola, right? That's what a happy parabola looks like. So what is the domain? The domain is its x values. The domain are the x values, which also means what is the graph doing from left to right? What is the graph doing from left to right? What are its x values? Well, on this left side, it's actually going to a negative infinity, right? It's going on forever and ever from negative infinity. And what's it doing on the right side? On the right side, where's the graph going? Well, it's going to keep going forever and ever that direction, which is a positive infinity. So that is how we're going to write it. They want it in interval notation. Does it ever reach infinity? No. So you put parentheses to indicate that it actually does not equal infinity because it can never reach that. So that is our domain. Our domain for our final composed function is negative infinity to positive infinity. Okay, this next problem, we are going to take the r function and divide it by the t function. So right there is my r function. There is my t function. Again, we're still going to find the domain and write that in interval notation as well. Okay, so the r function says x squared plus 8 in the numerator, and it's being divided by t in the denominator, so x plus 4. Okay, so this is just giving us a rational expression, which is just a big old fraction. We have a numerator, we have a denominator, but they are expressions, so we call it a rational expression. But can we simplify x squared plus 8? Nope, there's no way to simplify that. We can't factor anything out of it. So that numerator is as simple as it's going to go. And the denominator is also x plus 4. That's as simple as it's going to go. So that is our new function. The composition of our function is just this rational expression here. But we now need to look at the domain. So when we have a rational expression, we need to consider the denominator. The domain will be basically expressed in terms of what cannot be in the domain. The domain includes the x values. So whatever makes this denominator 0 is a big no-no. So that will be excluded values. So basically, we're just going to do x plus 4, and whatever makes that 0 is going to be the restriction or the exclusion to our domain. So that means minus 4 and minus 4. These are going to cancel. Oops. These are going to cancel. And then I have x is equal to negative 4. That is what will make this denominator 0, and therefore that means that our denominator is actually going to be x is not equal to negative 4. There will be an asymptote there. So if we were to like draw that on a number line, which we can do that, and sometimes it helps us to think about it. So if I've got a negative 4, there's a negative 4 on my number line, and it cannot be equal to negative 4, so it means open circle, but it means it could exist on this side of negative 4, and it could also exist on this side of negative 4. This kind of helps us to write our domain in terms of interval notation. If we put it on a number line, so on this arrow means it's going to negative infinity, and then it's going to go all the way up to the negative 4, and it's going to stop. Okay, so it's not going to be equal to the negative infinity. It's going to go all the way up to negative 4, and then it's going to stop. It's not equal to the negative 4. Remember, that negative 4 is going to cause that denominator to be equal to 0. But then that is going to be united with another piece of the domain. So it's going to start again at negative 4. It's not equal to the negative 4. It just starts at the negative 4. And then it's going to continue on. This arrow over here means it's going toward positive infinity. So this is how we would write our domain in interval notation. So there is my new function after I do the computation, and here is my domain for my new function. Okay, this one says we're going to take function s, multiply it times function t, and again, they're being evaluated for x, but x is already what's there, so nothing is really going to change. Okay, so s is going to be 2 divided by x. 2 divided by x. And that's going to be multiplied times the t function, which is x plus 4. So x plus 4. Okay, and that is going to give us 2 times x plus 4 divided by x. And there's nothing that we can cancel. There's nothing that we can factor out. So that's as simple as it's going to be. It is simply a rational expression. Again, when we have a rational expression, the domain considers this denominator. And it's going to be, the domain is going to be demonstrated in terms of the restrictions or what it cannot be. So we're going to set that denominator of x equal to 0, and we're going to simplify it, except it's already simplified. So this essentially means that x cannot be equal to 0. The 0 cannot be in the denominator. So again, we could, if we want to, we could draw a little number line, and we can put a 0 here, and it is not going to be equal to the 0, so it's an open circle on 0 because it is not equal to it, but it is going to go to the left side, and it is going to go to the right side, but there's going to be an asymptote where that 0 exists. So the way we write that for our interval notation is that over here, this arrow indicates that it's going to negative infinity. It's going up till it hits the 0, and then it's going to stop at the 0. The parentheses indicates that it's not equal to the 0. It just goes up to the 0, and we're going to unite that with the upper part of our domain, which is going to start at the 0, and it's going to continue on to positive infinity. So that is our domain for our rational expression. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.